So we looked at the future climate change as a whole for the whole planet and discussed the RCPs, the model projections, adaptation, mitigation, and some behavioral issues, some policy tools, and so on. But whenever you look at any particular place, then more of the region specific issues will come to the fore. This will decide the options in a much more specific way for that place. And what better place to look at than at India. And when we do the monsoon lecture, we will see that monsoon itself is also very unique, which will make the climate variability and climate change of the monsoon also very unique. Before going to that, we will look at some specific climate change that is being observed over India and what climate projections have been tried. You will see that the climate projections so far that have been tried for India are very primitive, but there is a massive effort going on right now. And so in AR6, there will be a huge participation from India, from an Indian model that will be more focused on Indian scenarios and so on. So let's start with some of the indicators that we look at for India in 2014 and what is expected in 2030. The population 1.2 billion, expected to go up to 1.5, but as I said, population projections are always uncertain because especially the impact of educating girls tends to be much more than expected. There are some theories that explain why rich women, educated women in fact have fewer kids. You think if there is more resources, they would have more kids. It turns out that again, the issue of allometric scaling that we discussed in biology comes into effect in a different way, where women who are educated and well off actually want to give each child as much opportunity for the future as possible. So they tend to have fewer kids and give each kid more wealth, more education, and so on. So that's rather not expected from evolutionary biology perspective, but that is what has been evolving in the 20th century into 21st century. The urban population is now around 377 million. That's an estimate from 2011, and it's expected to almost double. And the coastal population will also almost double. So there is a climate issues associated with that, as we saw energy consumption, water consumption, transportation and emission, building, heating, cooling, etc. will all be very unique for regions. So it needs to be considered when you consider mitigation adaptation options for the future. GDP at 2011-12, it's 106.44 trillion Indian rupees, expected to almost triple or quadruple, which is good news. Per capita GDP will go up as well, but as I mentioned, meat consumption, water consumption, energy consumption, fuel consumption, energy demand will also go up. So here is the per capita USD, US dollars. Those are getting into nice numbers in terms of the standard of living, but usually we talk about quality of life when we talk about air pollution, water pollution, congestion, ease of travel, infrastructure, and so on. Electricity demand will proportionately go up, as we can expect, almost quadruple. And in terms of the emissions, where we will be in 2030 and where we are at the current time, these are the various numbers we have already looked at. US and China, which should be somewhere, I cannot find it, but here is India, and the total for the world is now around 50 gigatons carbon equivalent per year. So India is somewhere in the range of 2 to 3, and it's expected to grow, but this projection is not showing a whole lot, especially if India continues to invest in solar and wind. Then our emissions and carbon dioxide growth contribution from us should be reasonable. Considering India is committed to Paris climate and what is called INDC, I mentioned before, intended nationally determined contributions to emission reduction, should be manageable if move to electric vehicles and renewables happens on pace. India has a comprehensive climate change plan, how to deal with it. So the main aim as stated by the government's plan is to put forward and further propagate healthy and sustainable way of living based on traditions and values of conservation and moderation. So, this will involve adapt climate friendly cleaner paths, reduce emission intensity of its GDP by 33 to 35% by 2030 from 2005 level. So, this is not saying directly reduce emissions. Obviously, it involves reducing emissions, but as I said before, we look at energy intensity of the GDP and carbon intensity of the energy. So, essentially you will be looking at emission intensity of the GDP. So, it is a slightly tricky commitment, but nonetheless it involves all the adaptation mitigation options, including how to manage forests, agriculture, energy use, etc. To achieve about 40% cumulative electric power installed capacity from non-fossil fuel based energy sources by 2030, create additional carbon sinks of 2.5 to 3 billion tons of carbon equivalent by 2030. So, through forests, maybe carbon capture, sequestration and so on. To better adapt to climate change by enhancing investments in development programs in sectors vulnerable to climate change, particularly agriculture, water resources, Himalayan regions which are considered very sensitive, coastal regions with sea level rise and warming and acidification, health and disaster management. Okay, that's obviously all needed. To mobilize domestic and new and additional funds from developed countries to implement the above mitigation and adaptation actions in view of resources required and the resource gap. Where are the resource gaps to make these goals happen? And to build capacities and create domestic framework and international architecture for quick diffusion of cutting edge climate technology in India and for joint collaborative R&D for future technologies. Especially HFC comes to mind, the main refrigerant right now, very long residence time of a couple of thousand years, very high global warming potential compared to CO2 almost 2000 times. So, this is a very bad greenhouse gas right now, and all countries have agreed that this should be replaced, except we do not know what the new technology will be, who will own it, how much it will cost. So, countries like India get some freedom to delay their transition from HFC, but nonetheless the countries have to be prepared, especially where it is getting hot and the demand for air conditioning is going up continuously. To achieve the above contributions, India is determined to continue with its ongoing interventions. So, there are already some adaptation mitigation that is going on that we will look at. Enhance existing policies as detailed in other sections of this report that you will have access to, and launch new initiatives in the following priority areas: new and more efficient and cleaner technologies for thermal power generation, promoting renewable energy generation and increasing the share of alternative fuels. So, right now even the most developed countries have a contribution of only 10 to 15% of renewable energy in the total energy portfolio. So, India needs to be much higher. I think it is right now less than 10%. Reducing emissions from transportation sector. So, switching to electric vehicles, government already announced that there will be a huge effort by 2020, ramping up into 2030 and so on. Obviously, there are infrastructures needed. If you have lots of electric cars or trucks, for example, you will need recharging stations all along the highways. That is not going to happen very fast, and that will also require energy production to be ramped up. So, all these things take time, investment, infrastructure and so on. Promoting energy efficiency in the economy, notably in industry, transportation, building and appliances. So, all the multi-story buildings that are coming up, they all have closed windows, they all rely a lot on air conditioning. Emissions from buildings can be very high. So, how to plan those things? And appliances, as economy grows, people become more wealthy and per capita GDP goes up. Number of appliances like washers, dryers, TVs, refrigerators will go up. Reducing emission from waste, this is a big task, and already many new technologies have evolved to recycle waste and maybe even produce energy from them. Developing climate resilient infrastructure, this goes for roads, bridges, dams, buildings, electricity supply, water supply, and so on and so forth. Full implementation of Green India mission and other programs of afforestation. So, India planted something like 12 million trees in just 1 year in 2015 or so, and that's a massive effort. So, such efforts are part of Green India mission. Planning and implementation of actions to enhance climate resilience and reduce vulnerability to climate change. And there is some primary research that shows that actually educating women also reduces their vulnerability to disasters. So, when a natural disaster happens, if a woman in the household is educated, she is better at receiving information, warnings, and take actions based on the instructions from local municipality or governments or whatever, and rescue the children, rescue the family from disasters and so on. So, vulnerability has many aspects to it: agriculture, individual, community level, and so on. This is a long list, but I will just tick off a few of them. Mitigation strategies have already been considered. Obviously, green generation of clean energy and energy secure India. So, energy security is a big thing because, as I mentioned, if the Middle East, which is a major oil supplier now, continues to get as warm as it is getting and the oil begins to run out, then all the conflicts they have will only multiply, and that problem will become energy supply problem for us and maybe other socio-political, geopolitical problems. So, that is something that has to be kept in mind when India aims for its energy security. National solar mission going from 20 gigawatt to 100 gigawatt by 2022, which is right around the corner. Solar powered toll plazas. So, even at a very low level, you have to start building infrastructures that are self-sufficient in terms of energy. National smart grid mission. So, the current electricity grid has to be changed to deal with intermittent sources like solar and wind and to reduce losses. Green energy corridor projects, nationwide campaign for energy conservation that has already been launched and shown to save energy, and there is a target for it. Smart cities mission, I think you heard about that. Cities like Pune, Bangalore, many cities, Hubli and so on are on the list. That includes saving energy, connecting all the decision making infrastructures through internet, and more efficient and clean sustainable environment, and so on and so forth. National Heritage City Development and Augmentation Yojana, Hriday. Atal Mission for Rejuvenation and Urban Transformation, Amrut. Launched the Swachh Bharat mission, which I think is a good mission if it can be implemented, especially if you consider every hut, every household wants to sweep the floor in the morning, but then we just tend to throw the trash just outside the gate. So, why is it that we are so particular about keeping the house clean every morning, but we do not take that to making the neighborhood clean? So, that is something to be worried about. It has an impact on climate, air quality, water quality. The stuff that seeps into water is going to affect us directly. Zero effect, zero defect with Make in India campaign, green highways, plantation and maintenance policies, faster adoption manufacturing of hybrid and electric vehicles. This is a new program that has got very high ambitions of transitioning to electric. First passenger vehicle fuel efficiency standard is already finalized. Policies to increase production of energy efficient 3-phase locomotives. So, these 2-stroke engines in India, which are all these rickshaws and motorcycles, which are very convenient and cheaper in terms of number of miles for liter of gas or petrol, actually emit a lot. So, that is something to keep in mind. Policy directives for biodiesel transition, National Air Quality Index. I will show some other numbers for this, because as I mentioned, air quality in India is one of the poorest in the world, and now there are numbers on how many people are prematurely dying from pollution in India. It's more than 1 million per year, and the lifespan lost is order 1 to 5 years for air pollution. Okay. Adaptation strategies, soil health, the Paramparagat Krishi Vikas Yojana, which is promoting organic farming. This reduces impact on both air quality and water quality, because organic farming has less leaching of nutrients and fertilizers, and there is some evidence that maybe with warming the crops are absorbing less micronutrients which are important, like iron, zinc and so on. With organic farming, maybe this deficiency will be improved. Pradhan Mantri Krishi Sanchayi Yojana, Niranchal, these are all various names, but they all have specific goals of watersheds, irrigation practices, which I will come to and show a figure at the end, as I mentioned before, relate to food, water, energy nexus. In other words, there is always a competition for water between domestic and industrial use, for food production and for energy production, and all of them together also affect health. So, the nexus means basically how they are competing for each other. There is a national mission for clean Ganga. We know that Ganga gets a lot of attention for being so dirty, and that is a massive task. Many institutions are involved in this effort, and it will take time. National Bureau of Water Use Efficiency is going to control the efficient use of water. Water appears in every aspect of climate change in every part of the world. Already many places are facing severe shortages. In India, 2018 has been a excess monsoon in some places, but there is still dry periods in other regions, as I will show in the monsoon talk. So, the distribution is very uneven, so water problems continue. Okay. Summary of greenhouse gas emissions in gigograms from India for 1994 and 2007. So, the energy emission from energy, industrial, agriculture, land use, waste and total national emissions are looked at. And if you just look at the main numbers, everything has gone up. So, the good news is that CO2 removal has also gone up. That is because of these increasing CO2 sinks by afforestation or planting trees. Methane emission has gone up little bit, and N2O emission has almost increased by 50%. So, the total CO2 equivalent emissions have massively increased. This is natural for any time you have economic growth. Right now, we do not know how to do economic growth without increasing energy use and emission. This is what has to change into the future, to reducing energy intensity of GDP and carbon emission intensity of GDP, right. So, this is by sector comparison. Again, the idea of comparing sectors, electricity, transport, residential and so on, is that you can set targets. If the increase in transport is much larger than, let us say, residential or so, then you need to reduce emissions in the transport industry, maybe by going to less diesel, more natural gas, more electric vehicles, more reduce the number of trucks and increase trains and so on. So, domestic flights are increasing, and airplanes are huge emitters of carbon dioxide, and with economic growth, number of airports will increase, number of people traveling within the country will increase, and number of Indians going abroad will increase. So, transport is going to be a big player. Energy production, of course, cement, which we did not mention thus far. Cement production for the whole world is a big emitter, and with construction booming, cement production in India is going to increase, steel production is going to increase. So, both iron, steel and cement contribute a lot. Agriculture has reduced a little bit, which is good news, but it needs to be reduced much more. Waste has more than doubled. This has to be reduced. With economic growth, production of waste increases, especially urban centers produce more and more waste. How do you move it? How do you save it? How do you recycle it or reduce emission from it, reduce landfills and groundwater contamination and so on? Those are also critical. And you can see that land use change and forestry contribution is huge. So, there has been a huge reduction in the emission from land use, basically abandoned forests, agricultural lands, urbanization and so on. So, forestation has also helped in that sense. So, the total land use change is also increased a little bit, but you can see that there are contributions that are reducing and there are contributions that are increasing. Obviously, for India, cattle and rice cultivation is a big contributor to methane. Flooded irrigation systems or flooded rice paddies emit a lot of methane. So, irrigated rice paddies, the area that is being irrigated is also increasing. Emission coefficient, methane emissions. So, rain fed is also significant, but less than irrigated. When you irrigate and you have water standing, emission of methane because of anaerobic respiration or vegetation getting soaked and emitting methane goes up. Deep water has some contribution and so on. So, these are essentially single aeration, multiple aeration, drought prone, flood prone and so on. There are details which we will not go into, but methane emission has to be tracked because methane is almost 25 times as much global warming potential as carbon dioxide. State-wise status of ambient air quality. So, as I said before, global warming has become a key phrase, but from the 70s itself, the data from the World Health Organization has been showing that impact of pollution on human health is pretty massive. So, if we focused on pollution and health, maybe the entire debate would have been different, but we have focused on global warming, and even changing that to global change or climate change is not so easy because the phrase is stuck. But now we have more and more details on what global warming actually means in terms of increased humidity, extreme rainfall, melting glaciers, rising sea levels, air quality, heat waves and so on and so forth. Tracking state-wise contributions obviously helps. As you can imagine, states like Maharashtra, which have lots of industrial activity, financial activities and big cities have huge amount of sulfur dioxide and NO2 emissions, and they also have what is called PM10 that is larger than many states, but here you would expect Delhi also to have a massive PM10 emission. So, you can see it is even larger than Maharashtra in both NO2 and PM10. What is PM10? PM basically stands for particulate matter, particles, particulate. 10 means larger than 10 microns or micrometers. So, PM 2.5 is so small that you won't even see it, but when you inhale it, it gets lodged in your lungs and creates all kinds of respiratory problems, asthma problems and so on. PM10 is also very bad for health, but it is so thick that you can actually see it when it hangs in the air. So, inefficient fossil fuel burning, crop residue burning, wildfires, chulas, diesel engines, coal burning, they all produce particulate matters which are really not good for health, human health at all, and they also have an impact on reflecting or absorbing solar radiation. So, when we look at how monsoon has changed in the past, we will see how the ocean warming has been different than the land warming because of these kind of pollution emissions. Okay, so, tracking each state will also tell you that we will see, we have already briefly seen that the winds over India come from the southwest in the summer, if India is here, and they come from the northeast in the winter. So, if one state is emitting more, it may be getting transported to another state in one season and transported to another state in another season. So, knowing each state's air quality helps you look at where the sources are and how they are being transported and where efforts have to be put in to reduce these emissions. This is the state-wise and union territory-wise forest area between 1987 and 2013. So, estimates going from 87 to 2013 for various states. I will not go through all the numbers, it is a very heavy table, but there are many regions where new states only started recently. For example, no forest change. Looking at Maharashtra, there has been some forest degradation. Delhi is a recent state. Shows constant, but actually Delhi is growing. It is converting a lot of the agricultural land around it into urbanization. This is a problem for many cities like Bangalore, Bombay, Chennai and so on. So, the forested area is very important to be tracked, but you can see here is the total that has slightly increased. Some regions have increased much more than others. The other important vegetation for India is mangroves, which are basically plants that grow in brackish water. So, like Sundarbans and so on. They set roots in the water and they grow above the surface. They do photosynthesis, they sequester carbon, they filter all the nutrients, they produce oxygen, and they provide a very rich habitat biodiversity for many creatures living in the water, small fish, crabs, shrimps and frogs and so on and so forth. And they are very good damping for waves. When the storm comes, the sea level is going to be damped by the mangrove forests and the storm itself is going to be damped by the mangrove forests. So, if you keep removing the mangrove forests, then you are going to make your region much more vulnerable to cyclones, which are actually increasing, as we will see. Okay? So, many coastal states going from Andhra to Goa, Daman, Diu and so on, they have had mangrove forests, and there is the total, just look at the total. It was 446 square kilometers, 4046 square kilometers in 1987, slightly above, but slightly grown over time, but there are many that have lost, which you can look at if you look more carefully. Let us see here, West Bengal has gone from 2076 to 2097. It had some drop, and then there were many efforts to recover mangrove forests. And there is also lots of diversion of forest land for non-forest use since the enforcement of Forest Conservation Act in 1980. So, Forest Conservation Act came into effect, and still lots of areas got diverted from forest to non-forest use over time from 1980 to 2004. So, it is very important to have these baselines. These we would call baselines. If you want to know what the changes are, then you must have baselines, so that you keep collecting these data going into the future and see how we are doing in terms of land use. Okay? Here are the various fractions of land use looking at 1991, 2000s, the next decade and the more recent period. So, I will not go into all the categories, but you can see that there is plenty of forested area and there are lots of other smaller uses. Agriculture has to be a big one, which is area under non-agricultural use, and permanent pasture and greenland, tree crops and so on. So, with satellites now it is very easy to do this. So, ISRO launches satellites, other countries launch satellites, and they measure pixels of 30 meters. So, from several hundred kilometers above Earth, you can actually look at what is in every 30 meter square on land and how it is changing over time. Okay? So, that gives you a very good handle on how land use is changing, because albedo changes, runoff changes, vegetation changes lead to carbon sequestration changes, food production changes and so on and so forth. This is the net irrigated area and percentage source for 1960 to 61 and 12 to 13. So, the water usage, you can see the irrigated area used to have lots of government canals. The wells were high in number, tube wells hardly existed, but now you can see that tube wells form almost 50% of the irrigation. And there are complicated issues, because many places are offering subsidized electricity for pumping water. So, even when there is good rain, farmers may be pumping water and irrigating land. So, it turns out that the irrigation has become completely disconnected from how good the monsoon is. This is not good news. So, that has to be controlled. So, government canals you can see have increased, but so have private canals and tanks. You can see tanks everywhere now, and the wells also obviously continue, but the largest increase is in the tube wells. They used to form 1%, now they are almost 50% of the irrigation. Water availability in India is a big problem. It has continuously dropped. So, the annual precipitation including snowfall total is about 4,000 billion cubic meters. Availability out of that is 1869. Per capita availability in 2001 was 1816 cubic meters, significantly dropped to 1588 cubic meters because of a combination of population growth, use for other activities, industrial, energy production, agriculture, irrigation and so on. And this number is dropping very rapidly, and that is not good news, because once you drop below about 1000 cubic meter, it is considered heavily water stressed. And we saw a map early on which showed that India has large regions where there is physical scarcity of water, and there are regions where there is economic scarcity of water. So, when you think of water, you have to always think about quality, quantity and access. There may be lot of water, but its quality may not be usable. There may be lot of water, but you may not be able to access it because of various social factors or economic factors and so on. So, that is something always to be remembered. And groundwater resources, India, especially Northwest India, Punjab remains one of the largest depletion rates. Almost 5 meters per year of water is being withdrawn. So, it is independent of how good the monsoon is. Again, that is not good news. Okay. This is part of climate variability and climate change, of course. Water quality in Indian rivers is being tracked, which includes obviously temperatures, pH or acidification of the water, conductivity, which is a measure of salinity. So, how salty is the water getting? That is not always good news. So, a lot of irrigation makes the soil salty and the water that runs off salty. Why? Because a lot of the irrigated water basically evaporates and the salts are left behind in the ground. It really begins to degrade soil health. Remember, the government has plans to have soil health cards. One of the reasons is because the salinization of soils is very large in heavily irrigated areas. Dissolved oxygen and biological demand of oxygen is a measure of how the microorganisms and so on in the soil that are important are degrading, and how soil is becoming less nutritious and bad for crops and so on. And this in the rivers and lakes, obviously that is bad news for fish and other things that are living in the water. And this also biological oxygen demand refers to chemical contamination, how many chemicals are withdrawing oxygen out of the water. So, this is total coliform, which is bad for your stomach, and fecal coliform, which is because people are releasing waste into the water. So, Ganga and Yamuna obviously remain poster children for bad water quality because of heavy population, misuse of the waters for all sorts of purposes and so on. Registered motor vehicles, if you want to track emission, obviously you need to be aware of what the transportation sector is doing. If you look at the numbers from 2010 to 2011, non-transport and transport vehicles, obviously numbers are increasing. Every city like Bangalore adds many lakhs of vehicles per year, already very congested. The more you idle, the slower you are moving, the more inefficient is the vehicle use. So, all traffic jams are huge point sources of emission. They emit. So, if you are living near a highway or living in a city, the pollution levels from emissions of vehicles is very high. So, the Karnataka, which is growing economically quite fast, obviously is also acquiring lots of vehicles equally fast. So, it includes cars, tractors and so called non-transport vehicles and so on and so forth. Again, just keeping the baseline is very important. Electricity generation from public and private sectors increasing, which is needed for economic growth for sure, but the question is how is it happening. So, the gross generation of power by source, hydro growing, steam growing, but steam usually means burning coal, which is not good news, diesel and wind. Diesel is a very bad emitter, very inefficient fuel, not good. Gas has much lesser emission, so that is better. Nuclear is considered good energy source because its carbon emissions are low, but you know that nuclear power plant needs a lot of free area around it. Nuclear disasters are always a scary thing, and where you get your nuclear fuel, how much mining is happening to extract the fuel has other land use impacts and water quality impacts and so on. So, that is the total. So, India obviously needs energy and will continue to produce more energy. India obviously has lots of coral reefs because it has almost 8,000 kilometers of coastline and it is a very warm ocean, and it has islands like Andaman, Nicobar and Lakshadweep and so on, which are hot spots for corals as well as ecotourism as well as warming and acidification and so on. So, here is Lakshadweep, Gulf of Kutch, Gulf of Mannar, Andaman Nicobar, and they all have various types of waters and corals, and there is evidence that acidification is happening quite rapidly. Every time you have warming, you have also acidification for sure, because CO2 is also going up. The same CO2 that is causing warming is also causing acidification. So, monitoring these corals is very important because it also tells you how the land runoff is changing, how the water quality is changing, how the fish production is changing, because India has a substantial population that depends on fish for protein and so on. So, let us stop with this, looking at retreats of some glaciers in the northwest Himalayas from Triloknath to South Terong, including Siachen and so on, the various river basins from Chenab to Ganga and Nubra, the time periods over which we have data, number of years for which we have data, some of them are fairly long, this one almost 150 years. This is the retreat of the snout in meters, and this is the average retreat in meters per year. And you can see that they are all retreating. Okay. So, if you already have water problems, you already have water quality problems in rivers like Ganga, Yamuna and others, and if they have contribution from glaciers and the glaciers are retreating, obviously that is of huge concern. As I showed early on, in the Himalayas are a complicated region. If you go from east to west, in the east you have more monsoon and El Nino effects, in the middle you have more monsoon, Indian Ocean and El Nino effect. In the west you have much more of the so called westerly disturbances or systems that are coming from the Mediterranean and the Atlantic. That matters because this have more summer rain and summer snowfall, whereas these will be more alpine or more winter snow and winter precipitation. So, the story is bit complicated. Karakoram seems to have more of a balanced state as opposed to the others which are retreating much faster. So, these kind of things have to be kept in mind because Indus River, which has conflicts, Ganga River which has so many people relying on it, agriculture and so on, their water sources depend on Himalayan glaciers. So, we must track what is happening to Himalayan glaciers. So, we will continue the India story when we come back. See you next time.